before the $2 billion Bybit hack, I designed and released software that would have mitigated that. Because I realized that when you condense entropy, so the problem with the Bybit hack is like, you're looking at your ledger, your Trezor, and basically your human mind is like, okay, how do I make sure that these two numbers are the same? And you're checking like the first little bit of the numbers and the last little bit of the numbers. And, you've turned a high entropy thing down to just looking at like a subset and making sure that those match. And so, let's be a little more creative and say, let's generate an image that a human can describe and easily compare. A poor example of this might be like a static image. Two examples of like images of static and just like black and white specks. You would say, well, I don't really know how to describe the difference between these two. So you could involve, a series of geometric shapes and different colors at different orientations and make a very high entropy layered image that is very difficult to reproduce in brute force. So I'm applying that right now to the BUBI project. Basically what I'm realizing is there's an opportunity to ensure that the users who are being delivered the client web app, you could say, there's a human user on their smartphone, and so they're going to go to some ClearNet web resource, some IP address. They're downloading that client, but how do we know we got a legitimate client? Because, we don't want to give our keys over. We don't want to interact maliciously. Well, one way to do that is to say, okay, let's construct one hashed output, one deterministic output from the infrastructure providers. So that would be the mirror who's providing that front end, the archival node who's providing some data, and then the client can say, okay, well, I can reconstruct the state of all of that information and then compare the hash to what has been stored on the blockchain. So that's trust minimized. Once you get the data, it's very difficult to reproduce the hash function that's been stored on the blockchain. But how do you know you're getting anything legitimate at all? And the right way to do that is to have another deterministic output paired between the client front end that has two separate kind of sigils that are produced. And one of them is a daisy chain of all of the infrastructure providers. And you want that to be different than your peers, such that those infrastructure providers cannot collude. And then secondly, you want to ensure that there's a Bitcoin sigil, and that is the deterministic combination of the events that are stored directly on Bitcoin. And so you can know that that sigil should be the same as any of your peers. So now if I'm interacting with my peers and we both open the web app, we could say, okay, sigil number one, we want it to look very different and not have any overlap. Okay, cool. You have, a red elephant on Mars, and I have like a purple flamingo on a Lamborghini. And then there's a second sigil that is the production of the Bitcoin blockchain, and that should match. And so the cool thing is, if that one matches, then we know that our client interface and all of the other data that we've collected, all of the people in between have provided valid inputs. And so that's pretty cool. So you can kind of validate the whole supply chain digitally. You're authenticating the humans who have claimed that infrastructure. And you can build a pretty easy way to enable third-party services to arbitrarily detect that and play whack-a-mole. So yeah, that's what I'm working on and thinking about right now. And then kind of the next step is to figure out how to break up all of these different like bundlers and all of the different archive nodes and the anchorer. So somebody has to be paying the fee to imprint everything on Bitcoin. And also the protocol needs to be upgradable over time, making sure that there's some kind of voting protocol in place, making sure that there's a trust minimized exchange between Bitcoin and the native token on this chain. So, trying to make sure that the cryptographic signatures that are possible here are both, interactable with Bitcoin and interactable with the Lightning Network. And you can do like arbitrary upgrades of N of M peers and make sure it's quantum resistant. So we're going to be using whatever is best in class. We're talking about Kyber. and dilithium. Yeah, so, and I think that makes a lot of sense. So we're just trying to make sure that that schema fits together and make sure that we can, in the OP return on Bitcoin, kind of stamp in an index of aggregators, and it's anchored right there on Bitcoin. So clients can validate that arbitrarily and get those pointers to the ClearNet web resources easily, and then all of that data becomes trust minimized, which is really sick. So bye bye fake news. Bye bye.